In this video, we solved problem 4 of Unit 14. In this problem, we have protons and alpha particles that have very different speeds, but all of them move along the x-axis in the positive direction. And at first, the penetrated region where there is a uniform electric field and also a uniform magnetic field, and both are perpendicular and provided in the first part of the problem. So the first question is, they ask us to determine the speed of the protons and alpha particles that can traverse this region undeflected. Okay, and this, if you realize, this is a velocity selector. So we studied that for this kind of configuration of electric and magnetic field, only those particles, those charged particles that have a speed in magnitude that is equal to the ratio between the electric field and the magnetic field, and of course the velocity has to be perpendicular to both, which is which is stated already in the problem. Only those can traverse this area. So this is equal to 1.6 10 to the 4 volts per meter divided by 0.5 Tesla. So this provides a velocity of 3.2 times 10 to the 4 meters per second. Okay, so now once both particles, alpha and protons, have this speed, they enter a region where there's a magnetic field of 1 Tesla, as shown in the drawing. So you have a region where there is this is the x-axis, this is the y-axis, and then you have the particles that are moving towards the right. That is the speed, and the magnetic field is going out of the screen. So that's why we plotted it as points in this area. Okay, so in this case, V, the velocity, is perpendicular to the magnetic field. So the magnetic force exerted on them is just the product of the charge times the velocity times the magnetic field. And once you do this, you can see that if as the particles are positive, they are positively charged, then when the velocity is towards the right and the magnetic field is out of the screen, you're going to have a force that is going to be this kind of force. So this is going to provide you with a circular path. Okay, and what they're asking us to do is find the radius of this path. So we already studied that the radius of this path is going to be equal to the mass times the speed divided by the charge and the magnetic field. So now we want to see that what is this radius for the alpha particles, which is going to be the mass of the alpha particles times the speed, which is the same for both because they both came from the same velocity selector, divided by the charge of the alpha particle and the magnetic field, which is 1 Tesla in this case. And for the proton, this is the same, but changing here the mass of the proton and here the charge of the proton. Okay, so you just need to know that the charge of the proton is 1.602 times 10 to the minus 19 coulombs, and the mass of the proton is equal to 1.67 times 10 to the minus 27 kilograms. And you also need to know that the charge of the alpha particle is twice the charge of the proton, and the mass of the alpha particle is 4 times the mass of the proton. So with this data, you can see that the radius for the alpha particle is going to be 6.68 times 10 to the minus 4 meters, and for the proton this is going to be 3.34 times 10 to the minus 4 meters, which is just half of it.